All right, section 10.2 is all about 45, 45, 90 triangles. So I would write that at the top next to 10.2. That we are going to be talking about 45, 45, 90 triangles. For our warm-ups, 1 and 2, we should be able to do because we practiced that yesterday. 1 and 2 ask us to use the Pythagorean theorem. So what formula do we use when we talk about the Pythagorean theorem, Angel? Angel, your voice sure did change.
I mean...
A squared plus B squared equals C squared is correct. So they already labeled for us which side was missing. So on number 1, what do you want to plug in for A? Okay, so 6 squared plus what's going in for B? 8 squared equals C squared. What is 6 squared? 36 plus 8 squared
64.
equals C squared. 36 plus 64 is 100. How do we get C by itself? Do what?
Square root.
Square root. Both sides. And what do we get for C? C equals 10. Good. We don't need a radical anymore because 100 is a perfect square number. Number 2, we have the same type of problem. This time, which variable do we not know? A. So we leave A squared plus. What goes in for B? 12 goes in for B. What goes in for C? 15. All right, somebody already said 12 squared is 144. What about 15 squared? 225. Now let's pause for a minute real quick. How did we know which number was B and which one was C?
C is always across from the right angle.
C is always across from the right angle. Okay, C is always across from the right angle. All right, what do we need to do to get A alone?
Subtract 144.
Okay, we subtract 144. What do we get for A squared?
81.
81, and then
Square root.
square root. What do we get for A?
9.
9. Good. On the last 2, we have isosceles triangles. So if we know that these 2 angles at the bottom, we call them the base angles, are congruent, then what is true about the sides across from those angles? They're also congruent or equal. So we can set up an equation to find x. 24 equals 2x plus 8. Those 2 sides have to be congruent if the angles across from them are congruent. How are we going to get x alone? Subtract 8 and then?
16.
Divide.
Okay.
By 2.
Good. And then we would divide both sides by 2. So x equals
8.
8. All right, finally on number 4. On number 4, we have another isosceles triangle. This time, the sides are marked congruent, so we have to know that the angles across from those sides are also congruent. So these 2 angles have to be the same. So again, we can set up an equation. 5x minus 18 is equal to 47. How do we solve for x this time? Add 18. 5x equals 65. Oh,
Divide 5x.
divide by 5. X equals 13. Yes. All right, on these, the X is on the hypotenuse on all of them, even though it's a little spaced funny. So get these copied down into your notes, and just like we did on the first couple of warm-ups, try using the Pythagorean theorem to find the long side, to find the hypotenuse. So on all of these, when you're setting up your Pythagorean theorem equation, what side are we missing? A, B, or C?
C.
C. So every time we're missing C on these. Get them set up, start working through them, and we'll talk about them in a minute. All right. So we already said that on all of these, we are going to be looking for C. That's what our missing side is on all of these. So for number 1, we're plugging in 8 and 8 into A and B. So 8 squared plus 8 squared equals C squared. What is 8 squared? 64. So we're taking 64 plus 64. What does that give us?
128.
So 128 equals C squared. And then what are we going to do to get C alone? Square root it, just like we were doing in those warm-ups. So we square root both sides. When we go to simplify the square root of 128, what do we get?
8 radical 2.
Good, 8 radical 2. So we can split 128 into 2 times 64. 64 splits into 8 times 8, so we have a pair. Remember, if you want to keep your trees going and keep breaking down 8s, you can. But once you get a pair, you can stop. So here, C is equal to 8 square root of 2. If I show of hands, how many people got that on their own? Good. All right. Number 2. We are going to take 4 squared plus 4 squared equals C squared. 4 times 4? 16 plus 16 is 32. To get C alone, we again have to square root both sides. Is 32 a perfect square number? It is not, but we can simplify it. What do we simplify it to? 4 root 2. Interesting. Oop, not squared anymore. Do we need to see 32 broken down, or are we okay with the 4 root 2? Anybody want to see it broken down? Yeah? So if we take 32, we break it into 2 and 16. 16 breaks into 4 times 4. So we have a pair of 4s and a 2 that's alone. So 4 root 2. All right, on to number 3. What am I plugging in for my A and B? 5 for both of those. 5 squared plus 5 squared equals C squared, or I guess we could be plugging in X. I've been using C. All right, 5 squared. Hopefully more than one person knows that. That is 25. 25 plus 25 is 50. Okay, then we have to do what? Square root both sides. Is 50 a perfect square? No. But it simplifies to be 5 root 2. 50 would break into 2 times 25. 25 breaks into 5 and 5. That's where we get our pair. If you have not noticed a pattern yet, I'm hoping that we're about to see it. Okay, so our guess ahead of time is that the answer will be 3 root 2 on this one. So let's check it. A and B are both 3. What is 3 squared? 9 plus 9 is 18. What do I do to get C alone? Square root them. 18 is not a perfect square number, but it would simplify to be.
9.
Okay, 18 would break into 2 and 9. 9 breaks into 3 and 3. So our answer is 3 root 2. Not squared anymore. C equals 3 root 2. Okay, on all of these triangles, if we have two sides that are marked the same, what type of triangle would they be? They are a right triangle because they gave us that box. But if you have two congruent sides, what do we call it? Isosceles. Okay, so these are all isosceles triangles. If these are isosceles triangles, what's true about the two angles that are not marked? They're congruent. Good. If these two sides are congruent, the angles across from them are congruent. So I could go through and mark all these angles as being congruent to each other.
You also tell us.
If these are right triangles and two angles have to be congruent, the other two angles, we should be able to figure out what those two angles have to be. We know all three angles have to add up to what? 180. We know we can take off 90 right away. What's 180 minus 90? 90. And we have to split 90 between those other two angles equally. What's it going to be? 45. So both of these angles are going to have to be 45. Does that make sense? This is bringing together a lot of information that we learned last semester. Okay, if we know all of that, let's get to the slide with our notes on it for today. Okay, so you will notice that all of the answers from the last slide were the number times the square root of 2. That was our pattern. So the standard template for a 45, 45, 90 triangle is that we have two sides that are the same, so they've labeled them here X and X, and that the hypotenuse, the longest side, is X times the square root of 2. Okay, I would also mark on your little triangle that either of these angles are congruent, or I would write in that they are 45-degree angles, so that you know this is only true for 45, 45, 90 triangles. Okay, the two legs of the right triangle have to be the same. The hypotenuse is going to be a leg times the square root of 2. These ones should go pretty quickly. Okay, the two sides that are marked congruent obviously have to be the same. The side across from the right angle is going to be one of those congruent sides times what number?
2.
Not just 2. The square root of 2. Okay, so if we've got a leg that's marked as a length of 7, and these two are marked the same, this one at the bottom is also a 7, what is the hypotenuse going to be? What is it?
49.
Not 49. What did you say, Kiatha? 7 root 2. That's it. The leg times the square root of 2. So 7 root 2. That's our answer. That's it. So on number 6, what do you think the unknown side is? Brandon? 15 root 2. We could be doing these the way that we did 1, 2, 3, and 4, where we also put a 15 down here and we do a squared plus b squared equals c squared. We could be doing all of that. The reason we're learning this is because this is a shortcut. If you know you've got a 45, 45, 90 triangle, which we do because it's isosceles and it's a right angle, then it's a lot easier to just use this pattern to find our missing sides. So who can tell me what they think x equals on number 7? 20 root 2. Okay, it's the leg times the square root of 2. Questions on 5, 6, 7? All right, on number 8. What's different about number 8 from 5, 6, 7? They already have the C side. They already have the longest side marked. Now we're looking for a leg. So it's going to be 18. Okay, if the hypotenuse was 18 root 2, if we were to divide that by root 2, that gets us back to a leg. That has to be 18. It might help to write yourself a little note on these. That for a 45, 45, 90 triangle, the hypotenuse, or h, is equal to a leg, or L, times the square root of 2. Hypotenuse is equal to leg times square root of 2. If I wanted to get the L alone, or if I wanted to know a leg, what would I have to divide both sides by? By what? By root 2. So a leg then is going to be equal to the hypotenuse divided by square root of 2. So I might add this in your notes as a helpful hint. Of course, H means hypotenuse and L means leg in this case. We didn't really need these on the first set of problems right here, but on the next set we might need to use those a little bit more. On number 9, are we missing a leg or a hypotenuse? We're missing a leg. So for this one, I would use the information that a leg is equal to the hypotenuse divided by what? The square root of 2. Okay, so instead of a leg, I have x. I'm going to move that out of the way for a minute. I've got x equals, what's the hypotenuse? 36. And we're dividing that by the square root of 2. But you may remember from last semester, or if you don't, I'm about to remind you now. Can we have a radical in the denominator? No. Does anyone remember what we multiply by to get rid of it? Not just 2. We multiply by radical 2 on the top and the bottom. This is what we called rationalizing a denominator. Multiply by the square root of 2 on top and bottom. Now on the bottom, the square root of 2 times the square root of 2. What does that equal? 2. Okay, it would be the square root of 4, which simplifies to just be a 2. And on the top, we have 36 times the square root of 2. Can those combine in any sort of way? No, not really. So we just write it as 36 root 2. But when we write that fraction, what do we notice can simplify? 36 over 2. If they're both outside of a radical, then they can simplify. What's 36 divided by 2? 18. So in this case, x actually equals 18 root 2. Now these are not meant to be hard, however, students don't tend to like it when a leg has a square root of 2 in it. Okay, that's why I'm recommending you use this sort of formula to help you decide if you're finding a leg or finding a hypotenuse, which way it's going to go. So this is our answer.
So 10 be 12 root 2?
Well, let's see.
5 root 2 is.
We're noticing some more patterns. That's good. On number 10, so that's over here. I don't have it labeled anymore. So I can put the number 10 back on there. On number 10, are we looking for a leg or a hypotenuse? We're looking for a leg, so we're still going to use hypotenuse over 2. So x equals, what's my hypotenuse? 24 over the square root of 2. But I can't have that radical in the denominator, so I multiply the top and bottom by
2
radical 2. Okay, and the top, 24 root 2, just stays 24 root 2. If I take the square root of 2 times the square root of 2, I get square root of 4, which is 2. And it looks like perhaps our predictions were correct. X equals what? 12 radical 2.
So can we do this like mentally, like just do it by work?
On these problems, I want to see a little work. Because these ones don't just follow the pattern quite as easily. Okay, there's a little bit more involved. Do we have questions about it? All right, we've still got a couple more to do. On number 11, again, we're looking for a leg. So what is my initial equation that I'm setting up? What's representing my leg or my L? X equals, what's representing my hypotenuse? 50 over radical 2. Good. Okay, we have to rationalize. So we multiply the top and bottom by radical 2. What does that become? Very good. 50 radical 2 over 2. And that finally simplifies to be 25 radical 2. Good. All right, we've got one more on here. What's my initial setup?
So what happens if you got a radical for your hypotenuse?
What happens if you have a radical in your hypotenuse?
Yeah. You have to multiply like we been doing.
So let's get through number 12 and then we'll change it and look at one with a radical. So let's do number 12 real quick before we look at that example. How would I set up number 12? What comes after the 10? Where does it go? Oh, good. All right, we multiply it by radical 2 over radical 2. Good. Good. 10 radical 2 over 2 simplifies to be 5 radical 2. Okay. Do we feel okay about these? Usually, students do fine if the problems are isolated, meaning this was all basically the same type of problem. So you saw the pattern, you recognized it, you could apply it. Same thing with the last slide. You saw the pattern, you were able to apply it. What gets confusing is when we start mixing them in together, which is what you'll see on probably your homework in a quiz or a test. So let's look at one like Martez was asking about. So if I have a triangle here, right triangle, it's isosceles. I label that as my X. And Martez, did you want your hypotenuse to have a radical 2 or some other radical?
Some other radical.
Well, which one would be the hard? It'd be the hardest one for radical 2?
It'd be hardest if it had some other radical.
Some other radical.
Okay. So if it has some other radical, so let's call it 10 radical 5. Do I want to do 5? No, let's do 6 instead. This will probably be the hardest type. Okay. What are we missing? A hypotenuse or a leg? A leg. And the leg is equal to the hypotenuse divided by square root of 2. So what is my leg? X is equal to, let me move that down. My hypotenuse is 10 radical 6, and I have to divide that by radical 2. Okay, so then we just talked about rationalizing that. I'm going to multiply top and bottom by radical 2. So my steps so far are the same, but this time when I do that in my numerator, what can get multiplied together? The radicals. So I would have 10 radical 12. And what about my denominator?
2.
Just a 2. So now a couple different things can simplify. We already know that the 10 over 2 can simplify. What would that be? That would be a 5 radical 12. Right? If I just simplify the 10 over 2. But what do we notice about radical 12? That can be simplified also. Okay, so radical 12 would break into, okay, we could have 3 and 4 or 2 and 6. 4 breaks into 2 and 2. So what do we have a pair of? And what's alone? 3. Okay, so the 2 is going to go where? Outside. And what happens to it? Multiplied by the 5. So it becomes 10. And what's inside the radical? The 3 that was left alone.
That's not wrong.
I would recommend writing that in your notes if you need that as an example. Okay, I will leave it up there. That is a wonderful example of a more challenging type of problem. Do we have any other questions? Okay.